Hi, I'm Don Pizzette, co-founder and edutainer at IT Pro TV. We've curated a playlist of select episodes so you can get an idea of what it's like to choose IT Pro TV for your IT learning. It wasn't easy. There are more than 4,000 hours of IT training on IT Pro TV. Enjoy this episode and be sure to subscribe so you won't miss a thing.
You're watching IT Pro TV.
Welcome to another great episode right here on IT Pro TV. You're watching the AWS Certified SysOps Administrator Associate Show. I'm your host, Ronnie Wong, and today we're going to be taking a look at RDS availability. That's right, taking a look at the idea of relational database services. And here, of course, to help us is Mr. Database himself, Don Pizzette. Don, welcome to the show.
Hey, thanks for having me, Ronnie. I got to get a new name badge now, Mr. Database.
Well, there's somebody took up Mr. Robot, so we've got to do Mr.
We don't
Database.
want copyright violations. All right, well, in this episode, we are going to be taking a look at relational database service, and more importantly, how we create an available solution with RDS, right? So RDS is just a managed database instance that's deployed inside of AWS. It's pretty straightforward, right? But when we set up these databases, or even after the fact when the database is already there, there's a lot of things we need to be aware of to keep them up, running, and healthy even after a failure is detected. So we're going to walk through some of that. We'll talk about a few of the different database types inside of RDS and how each of them handles redundancy and availability. That's what's all coming up right here in this episode.
All right, so Don, with the idea of AWS and the availability that's already there, is there a lot that's different when we go to RDS availability?
There actually is. And when you go into RDS and you spin up a database, one of the first things you have to pick is pick from the range of database engines that are supported, right? So I've got RDS's page pulled up right here, and they show some of the engines that are supported. Amazon Aurora, PostgreSQL, MySQL, MariaDB, Oracle, Microsoft SQL Server. That's 6 different engines. And that's not even counting things like Redshift and DynamoDB and those guys. But inside of just RDS, there's these 6 different engines. Do you think they all work the same? Because they don't. A lot of them are compatible, right? So SQL, the structured query language or standard query language, depending on who you ask, it's the same across them. And so a lot of the basic commands like select statements and all that will work the same across all 6. But there are special features that are a part of each engine that differentiate them from each other, that make them more robust or more efficient in different ways. And then there's also just our personal preference, which one we happen to have the most exposure with and like. The most popular one is actually MySQL. MySQL is used by tons and tons of companies. It's sort of an open source product, but it is controlled by Oracle. So, you know, a lot of people view it as proprietary, but it is very widely used. Oracle would be the full-blown version that's incredibly expensive but incredibly high-performing. Microsoft SQL, same thing, but on the Microsoft side. Over time, there has been a bit of dispute over MySQL, and so there was a fork of it created called MariaDB. MariaDB and MySQL are largely the same. That, you know, one is an open-source fork that's controlled by a community versus one that's a open-source product controlled by Oracle. So a little difference there. But those two largely operate the same way. Amazon Aurora, though, is also a fork of MySQL, but it operates very differently. And that's because Amazon knows their hardware. They know what they have inside of AWS, and so they're able to create higher performance and higher redundancies with it. So depending on the engine that I pick, Aurora, MySQL, MariaDB, those 3 are practically the same functionality-wise. But on the availability side, they start to differ. And I skipped over PostgreSQL. Aurora is actually compatible with PostgreSQL as well, but it is a separate code base, and it handles things a little bit differently as well. So when we start working inside of RWS, we need to think about that. We need to think about which engine it is that we're supporting. And as you look at the pages for each, like if I look at RDS for MySQL, and we start to read through, it talks about how you have these easy deployments, and there's automated backup and recovery, and so on. We have high availability and read replicas that you can set up. Great, so it's highly available. And if we look at the Aurora page, it says, well, pretty much the same thing, that it's got high availability. It's in here somewhere here. High availability and durability. Great, so it's available. So what's the difference? There is actually a difference. If you dig around inside of Amazon's FAQs, you'll find a really cool table. This one right here. So let's pull this up here. That is highlighting the differences between Aurora and MySQL. Now remember, Aurora is a fork of MySQL. It's based on the same code base. But because Amazon knows their infrastructure and they're managing it, they can actually do a lot of really neat stuff. So for example, number of replicas. With MySQL, I can replicate my database up to 5 times. I can have 5 replicas. Now, with MySQL, and really actually with most of these, you can only have one writable master, right? You can have a number of read-only replicas that you do reads from, or you can have straight up replicas that are just backups. And we can have up to 5 of these backups available from MySQL. But you can have up to 15 with Aurora, a much bigger number. That might be super overkill for most people, so you might not care. But Aurora is able to do this because it takes advantage of some of the replication that Amazon themselves uses between their different regions. The replication type we'll see is pretty similar, except much higher performance on Aurora. It's measured in milliseconds versus seconds with MySQL. So, our performance impact on the primary, that is when we're taking a data off of the primary and sending it over to a replica, there's actually a good bit of performance impact in MySQL because you're snapshotting this database. Well, with Aurora, it's designed in the infrastructure, so very low impact to have that run. In fact, when you start doing backups of your database, you'll actually back up one of your replicas instead of backing up the primary. If they're the same, what does it matter which one you back up? So why put a performance impact on your primary when it can come off of the replica? And that's exactly what happens. When you do failover with MySQL, depending on your replication intervals, you could have several minutes of data loss. Notice it says potentially. Amazon actually does a really good job with this, and it's usually that you have very, very little data loss, but the potential is there. With Aurora, the replicas are in almost lockstep. And so any transaction that you lose would be an in-progress transaction, which you're going to lose anyway because it's not completed. So everything else that's been committed, you fully have on the replica. We do have automated failover on Aurora versus MySQL where we don't. On MySQL, when your master fails, it was the writable master. We have to promote a replica to become a new writable master, and that's a manual process by default. We can automate it with scripting and monitoring utilities, but inside of the database package itself, it doesn't do that. So it'd be a manual process. Aurora is managed, right? So they tackle that and take care of it. And then the support options here. Things like replication delays, you can't do under Aurora because it's in lockstep. MySQL, you can do delays. Sometimes delays are good, right? If I drop a table and there's a 15-minute delay, I've got 15 minutes to go and get that table out of another database. If it's in lockstep, I just lost the table everywhere. Same thing with different schema versus the primary. Your replicas in MySQL can actually have a different schema. I've never actually used that in any production environment, but I have read some white papers and scenarios where people needed that. Aurora doesn't have that support, again, because you are in lockstep. What's happening is MySQL and Microsoft SQL and PostgreSQL, they're all using software applications to be able to replicate the database from one place to another. But with Aurora, because it's integrated into AWS, they're doing storage replication, right? Independent of the database. So they know the storage. It's Elastic Block Store or EBS. Amazon controls that. And so they're able to replicate at the storage level to ensure the database is the same. And that's why we can't have a different schema. And that's how they can keep the replication delay next to nothing and so on. It's all because they understand the hardware. With MySQL, they don't know if you're going to run on AWS or Azure or on-prem or whatever, so they can't take advantage of that. With Aurora, Amazon knows where it will be, and they can do all these extra things. So the point of all this is not to be an Aurora sales commercial, which is kind of what I just did, but to highlight that our high availability is going to be different depending on what we choose. And I know my instinct when I go and launch instances to do MySQL, because everybody knows MySQL. It's easy to hire people that work on it. It's very standard. There's tons of books that are on it, right? That's my instinct. But if I go with Aurora, it's fully compatible and it has extra functionality in there that allows it to stay available and online. So that needs to be a factor in creating availability inside of RDS. The other thing is when we launch our RDS instance, we're going to be confronted with a number of options, right? The most important option is whether we want to do a multi-AZ deployment. If we don't choose that, we might be deploying our entire RDS environment in a single availability zone. And if that availability zone fails, so does my instance, right? Now, that's a decision we can always change our mind on later. It's not like we're bound to it. But let me show you here. I'm going to jump into my console, and I'm going to jump over to RDS. Get down into it. And when I go into RDS, I don't think I have any instances right now, so we'll spin up some new ones. Yeah, I'm going to go ahead and create a new one. When I whip up my database, the first thing it asks, what am I doing? Is this going to be Aurora? Is it going to be MySQL, MariaDB, so on? I'm going to go with MySQL, right? The main reason is Aurora is almost cheating at this point because it's going to set up things for me. You'll see where it has 6-way replication across 3 availability zones. That's pretty good, right? So just automatically, if I choose Aurora, 6-way replication across 3 availability zones, that's pretty slick, right? If I choose MySQL, right? Well, it supports doing multi-availability zone, but it's not on by default, so it's not even here in the list. In fact, the only thing they mention are cross-region read replicas. Cross-region read replicas are different than standby servers, right? I don't think I've used that term standby yet. When we talk about let me go back to Aurora, the 6-way replication across 3 availability zones, you'll have a writable master, and the others are all standbys, ready to jump in to become a master at a moment's notice. That's what they're doing. Those are not read replicas. I might still need to create read replicas other places. And you can create a number of read replicas, up to 15 read replicas with sub 10 millisecond replica lab. So that's separate. This is something that's hard for a lot of people to grasp. The standbys for the master are different than the read replicas. By default, you're not going to have any read replicas, 0. It's up to you to create those. If you have a heavy read website, you can create read replicas to move the read traffic off to them. The write traffic is still going to go to the master though. And when we talk about availability, if the master is getting overloaded with write traffic, what do? Well, we scale up. We can scale up to improve performance, and there's 2 ways to do that. One way through scaling up our CPU and memory. The other way is through scaling up our IOPS, our disk utilization. So I want to talk about that as well. We'll talk about that in just a second as I go through creating this. And if I switch over to MySQL, I'll see a lot of the same kind of data. Supports automated backup. We can do cross-region read replicas, but it doesn't mention 6-way, 3 availability zone replication of the master. I don't get that. It will, or it does support doing multi-AZ replication, but not by default. I'm going to choose MySQL and move forward. And when I go to create it, here's the important question for me. Well, first off, it says, hey, did you know you could do Aurora? and you would get all this other great stuff. But if I ignore that one, it's asking me if I want to do production or dev test, right? The main difference is multi-AZ deployment and provisioned IOPS, okay? Multi-AZ deployment. I'm going to have a writable master in one availability zone, and I'll have a standby in another availability zone. And if a failure happens, I'll be able to flip over to the standby. If I go dev test, I just get one writable master and that's it. No standby. I can still do backups, and I can still restore backups. Actually, if a failure happens, Amazon will restore the backup for me. But there'll be downtime. There'll be outage, right? The other master is not up and running for me. Provisioned IOPS. When we talk about disk I/O, depending on the amount of space that I allocate from my database is going to determine how many input-output operations per second I can write. That's what an IOPS is. Input-output operations per second. Well, if I've got a heavy read or a heavy write database, those combined, that's I/O, right? I/O includes both in and out. And when I allocate storage, that's shared storage with other Amazon customers. So I only get a certain amount of I/O. Well, depending on the size of my storage is going to determine how many I/Os I get, right? And if you look, if I create a 1 gig storage unit, I'll get 100 base performance IOPS. So I'm basically guaranteed 100 input-output operations per second. But I can burst. See how there's these bursts? You can burst up to 3,000 IOPS, right? Well, what happens is you're not always using your base 100 IOPS. And so when you're not using them, you start accruing credits. And you can burn those credits to burst up higher, up to 3,000 IOPS. Well, the more storage you allocate, the more your base IOPS are. And once you get to a terabyte, your base performance becomes 3,000 IOPS, which is the maximum burst speed. And so it no longer calculates credits for you. You've always got credit to burst because you can burst to 3,000 IOPS and you're guaranteed 3,000 IOPS. So you're now hitting your guarantee, right? So if you need less than 3,000 IOPS, then you can just increase the size of your storage and that will get you the increased IOPS. I might only have 1 gig of data, but I might apportion a terabyte database size to ensure I get enough disk I/O. And I know this doesn't sound like an availability and redundancy thing, but availability is all about the database being accessible when your customer needs it. And if it's getting overwhelmed, like you're running a Black Friday sale or Cyber Monday or whatever, if it's not accessible because of load, this will bring your database down. You know, your site will not perform. So we need those IOPS. When you get to 3 terabytes or 10 terabytes, you'll see it actually jumps up even higher to 10,000 IOPS, right? But that is a lot of storage to allocate, especially if we're not actually using it. So we do have another option. When we provision our instance, we could do provisioned IOPS, where I say, don't pay attention to the size of my storage. Here's how many IOPS I want to reserve, and we pay for that number. Now, we're paying for that number all the time, whether we use them or not, but you can reserve them. And that's another big piece of doing availability. So choosing production is really important. If you choose dev test, you can actually convert to a multi-AZ deployment after the fact if you want. But converting to provisioned IOPS is actually really hard. You need to take a snapshot of your storage. You need to restore the snapshot as provisioned IOPS and remount it. It's a bit of a nightmare. So if you're going to need provisioned IOPS, you should start with provision. And you can actually provision a really low number while you're in testing and then bump up what you provision higher later on. But it's actually pretty challenging to convert over to provisioned IOPS. So that's really what these choices are asking about. All right. And as I move forward, now, since I chose multi-AZ and I chose provision IOPS, when I come through and configure, it's going to ask me to pick my SQL version, and then it's going to ask me to pick my instance size. This is the other way we can scale, right? We have a certain amount of CPU and a certain amount of RAM, and I can bump up higher. I can change this after the fact as well, but it requires a reboot. So we want to try and minimize this. If I reboot my master, well, maybe I've got a standby that can take over as master for a little while. I reboot this one, and then I fail it back over. We just need to plan on that. If you have a multi-AZ deployment, that's easy enough. You can do it. But if you didn't do multi-AZ, now scaling up actually creates an outage. We usually scale up when we're under load. That's when we don't want an outage. So the multi-AZ deployment becomes that much more important. I also see where I can create a replica in a different zone. That's the multi-AZ deployment, which we chose. I could turn that off if I was crazy. But in my case, I want that. So I'm going to leave it turned on. And it tells me it's going to provide data redundancy, eliminate I/O freezes, and so on. That's what's going to facilitate that, as well as spikes during system backups. The backups will actually happen on the replica as opposed to on the main one. I chose provision I/O. And so here's where I can come in and actually set the amount of I/O that I want to reserve. If I want to reserve 10,000 IOPS, I can. It's defaulting to 1,000 for me. Hey, I might want to lower mine. Mine's not going to be doing much, right? But it's up to you. You can change this, and you can change it after the fact, which is nice. I'm only allocating 100 gigs of storage. Maybe that's more than I want, right? I could drop that down to 20 gigs of storage. And, oops, too low. 100 is my lowest, so let me do that. And so I can allocate that, a certain number, and then manually adjust the IOPS. If I wasn't doing provision IOPS, if I was doing general purpose, see how the provision IOPS bit disappeared, right? And it's telling me a little bit of information down here that I'm not going to get the greatest. I should consider doing something better. But as I increase, it is actually increasing the amount of IOPS. And now it's telling me, hey, higher allocation storage may improve IOPS. That warning went away. I'm going to flip back to provisioned. So I can go with those numbers right there. All right. And it's giving me the estimated cost on what it's going to take for this database to run long term. It's up to me to, determine if that's okay or not. I'll just call this my LabDB. And I'll create a user account for me, which is going to be awesome. Oops. And it is a little picky on what it allows for characters on the passwords in MySQL. And once that's done, there we go. Now it's going to ask me what VPC I want to stick it in. Remember, your virtual private cloud, we cover those in another episode, is going to determine whether this is publicly available or internally only. For security reasons, we may want it internal only. So you'll choose your VPC, a subnet group if you've got one designated. That's going to be usually tied to a particular availability zone. Since I've done a multi-availability zone, I don't actually need to pick a subnet group because I'm going to be in more than one anyway. And then public accessibility. So this is on the security side. Do I want it to be publicly available or not? If I chose a VPC that was private, it actually wouldn't matter what I chose here because you won't be able to get to it. But if I choose a public one, I can still choose to make the RDS not publicly available. It's kind of up to me how I want to do that. I'll leave mine as publicly accessible. All right. And then the VPC security group that we're going to use, we can create a new one, or if we already have one, if we've already got database server set up, we can just mirror that. And then I'll just call this my lab DB1. Oh, doesn't like the hyphen. Let me get rid of that. And that should be about all I need to choose on here. We can turn on encryption, again, if we need that for security. But then down here at the bottom, this is the next part I wanted to specify. We have backups, right? Now, a live replica, a standby, that's ideal, right? If my master fails, the standby can jump in and takes over. That's exactly what Aurora is doing for us, or a multi-AZ deployment, that's what it's doing for us. But that's all inside of a particular region. If a region fails and I need to restore somewhere else, right? Well, I want to have a backup. Or if I deleted something, if I drop a table and that comes out of the master, it's going to come out of the replica as well. Where can I go to recover that data? Your backups are what's going to do it. A multi-AZ deployment is not a replacement for backups. We still have to back up our systems. Otherwise, we're definitely going to have some issues there. So I need to choose how I back it up. Mainly, it's going to back up every day. So we've got that. You can determine the time. I can select a window, or I can just leave it no preference, and they'll choose when to back it up. And I can specify a retention period. They're only retaining these backups for 7 days. If you need them longer, you can adjust this. I think the max is like 35 days. So we can go up to 35 days if we want, or you can leave it at 7 and you can do your own long-term backups. And that's what a lot of people will do to back up offsite or back up to an S3 bucket or something like that. You can use the various utilities inside of the database software to get those backups out, and that makes life a lot easier. Aurora backups are really nice because they can be restored to MySQL and other engines. Like if you need to restore on-prem, you can, and vice versa. On-prem backups, we can use the database tools to restore those right into an instance inside of AWS. All right. We do have a bit of performance monitoring. We're going to talk about performance in another episode, so I'll leave that just kind of at its default. And same thing with performance insights. That should be about all that I need right here. Yes. So I'm going to go ahead and create that database and let that one drop in. Now, because I chose a multi-AZ deployment, it is going to create and build up the master. It's going to build up a standby, and it's going to start synchronizing data between them. It's doing all of that for me, and that is a lot of work, so I'm kind of glad that it's doing it for me. If I jump to my instances, I don't see more than one instance, though. All of that stuff is happening in the background so that we don't have to worry about it. I did mention that if we didn't set up a multi-AZ deployment, we could enable it after the fact. You certainly can. You can choose an instance, and under instance actions, it might not show up for me. Well, let's try. If you go under instance actions and choose modify, you can look at the settings on the instance. It's probably not going to work on mine because it's still spinning up, but you can actually come in here and choose to enable the multi-AZ after the fact. All right. Mine's telling me it's currently not in a modifiable state, but that's where you would go to be able to change that so you can kind of fix it later on. It's not the end of the world if you don't turn it on, but in the older deployments, that was always a problem. In the newer ones, you would be turning this on if you chose the test deployment, and the test deployment doesn't have provisioned IOPS. So we don't really make use of the test environment very much unless you're actually testing, in which case it's better to build a whole new production environment and then just back up and restore your database into production, and you're in business that way. So that's kind of the better option there. But all of that is what goes into creating one of these databases. The nice part is the availability stuff is all being set up for me. Amazon knocks that out. I don't have to deal with it. It's fully managed. Aurora is even easier because they're tackling all of it there on the background. Here, I mean, really, at the end of the day, I just had to choose multi-AZ. And now I have that redundant deployment. I've got my backups going as well. That's all kind of a key piece to getting a highly available RDS deployment.
All right, Don. Well, thank you again for helping us to take a look at this idea of RDS availability. Setting up the actual RDS and everything that we need to seems like it's fairly straightforward until it comes down to actually figuring out which exact instance that you need. And of course, the idea here of actually choosing whether it's going to be multiple availability zones or not. So just pay attention to that as well. Don, any final words before we sign off?
The main one is, each of the engines are equally supported. I know it sounds very Amazon Aurora heavy, and Aurora is great. If you can use it, by all means do. But their support of PostgreSQL and MySQL and MariaDB are all top-notch. Amazon has some of the best database administrators in the entire world working on their staff. So feel confident, no matter which platform you choose, that it is going to be well supported and very robust. But understand that each one is a little bit different. So you've got to understand what is supported by that particular database engine. Make sure that you've got the proper backup and restore as well as replication methods in place. Definitely keep an eye out for that.
All right, well, you heard it right here, and that means this is a great place for us to also sign off for this episode. For IT Pro TV, I'm your host, Ronnie Wong.
And I'm Don Pizzette.
Stay tuned right here for more of your AWS Certified SysOps Administrator Associate Show.
Thank you for watching IT Pro TV.